Edexcel Core Pure Calculus 3 Inverse Trigonometric Functions, integrating using arcsin x. We've previously seen that if we differentiate the inverse function arcsin x, that we get 1 over the square root of 1 minus x squared. And we've also looked at the more general case that if you differentiate arcsin x over a, you get 1 over root a squared minus x squared. However, we can start to extend this idea and start to look at integrating using this arcsin function. So if the derivative of arcsin x is 1 over root 1 minus x squared, what happens if we integrate both sides with respect to x? I'm now going to integrate both sides with respect to x. If I do the right hand side first, if I integrate this with respect to x, I need to use the correct notation, that the integral of 1 over the square root of 1 minus x squared with respect to x. If I integrate the derivative of arcsin x, so don't forget this is the derivative of arcsin x on the notation on the left hand side, so when it's integrated we will go back to arcsin x plus constant c. Likewise, in the more general case, we know the derivative of arcsin x over a is 1 over root a squared minus x squared, but what happens if we integrate both sides with respect to x? So if I do the right hand side first, I need to get the notation right, so that's the integral of 1 over the square root of a squared minus x squared with respect to x, so that's a dx. And if I integrate the derivative of arcsin x over a, then I will go back to arcsin x over a plus a constant of integration c. So now, having derived these derivatives in previous sessions, we can now integrate both sides with respect to x to create this new integral, which allows us to integrate these new functions 1 over root 1 minus x squared. And likewise, if we integrate both sides of this general form, it allows us to integrate functions of the form 1 over root a squared minus x squared. So here in this example we want to integrate 1 over root 4 minus x squared with respect to x. Before you start on integrals like this, it is advisable to get it into the correct form, and the form we need is something like a squared minus x squared. So simply rewriting it as 2 squared minus x squared will help you get the right answer. In other words, we are looking for the case when a is 2. So using the standard result, I can now write this straight off as arcsin x over 2. Remember, a is 2, and don't forget the plus c for your constant of integration. So the thing to remember here is that that simple little rewrite as writing 4 as 2 squared and identifying the value of a will help you when you come to do the integral and use the formula that we've previously seen. So in this question there's a little bit more to think about. We've got 2x squared this time, so before I deal with the 9 I'm going to rewrite it. I'd like it to just be 1x squared. So the first thing I'm going to do, integrate 1 over the square root. I'm going to pull a 2 out as a common factor, so this will become 9 over 2 minus x squared. Okay, I'm going to bring that 2 outside the surd, outside the square root, so it's going to become a 1 over root 2, and we will be left with 1 over the square root of 9 over 2 minus x squared. So that's made it much nicer to deal with. We've only got the 1x squared there, but it might be worth rewriting the 9 over 2 as well, just to make sure that everything's exactly as we would like it to be before quoting the result. So if we want to be a little bit more cautious, I'm going to write 9 over 2 as 3 over root 2 squared minus x squared dx. Now it's much clearer that a is going to be 3 over root 2. I've clearly identified what a is from here. Now I know what a is, I can quote the result as 1 over root 2 arc sine, and we need x over a, so that's x over 3 over root 2. Don't forget the plus c. This term here is a little bit unnecessary. We can tidy that up a little bit. So I would write this as 1 over root 2 arc sine, and if I times the top and bottom of this fraction by root 2, I get root 2 over 3 times x plus c. And there is the result of doing the integration. So the couple of things to take on board here: it is worth pulling the 1 over root 2 away from the integral in order to get 1x squared, and then it's worth rewriting 9 over 2 as 3 over root 2 squared in order to identify what a is, and then quote the result very carefully, particularly with a being a fraction. Make sure you put everything in exactly the right place. So this standard result can be quoted, and the things to watch out for: I would recommend having a coefficient of 1x squared there, and make sure you identify exactly what a is before quoting the result arc sine x over a plus c. If the coefficient of x squared isn't 1, as we saw in the previous example, then it's worth pulling that coefficient out as a common factor in order to make sure that you do have just 1x squared. In the next session, we're going to be looking at integrating using arc tan x.